Dear guests, faculty and students, good morning and welcome to the annual Stevens Research and Entrepreneurship Day. On behalf of the Stevens community, I would like to thank you all for joining us in a celebration of another great year of groundbreaking research, innovative education and entrepreneurship. There is a lot of exciting news in research and technology development that we will report to you today. The day is packed with presentations and technology demonstrations by our faculty and students, the fuel that powers our innovation engine.
I would like to welcome all of you to this very special day where we showcase the research work of our faculty, our students, both undergraduate and graduate, and we try to really highlight the connections between our research and the needs of society through the connection between innovation and entrepreneurship.
I want to thank each of you, all these three groups, being here and helping us develop and expand our network and our partnership in this endeavor, which is research and entrepreneurship. And at Stevens, we've always been together. Those two things, although different people do different things, they will go together because entrepreneurship and innovation is the undercutting theme across the board of everything that we do.
My vision, looking down the road, is that by the work that we all do, the nation's more resilient. We as a society, resiliency also means efficiency. You move stuff, you move people, and you move electrons better, faster, cheaper, and our lifestyles improve.
You're going to see today a very broad range of technologies and started companies that really represent a much wider technology perspective than you would anticipate at a school of Stevens' size.
I appreciate the opportunity to talk with you today about some of AT&T's innovations. 20 years ago when I started with the company as a software developer, I was impressed because we had more computers than we did people. So I didn't have to wait in line and didn't have that budget of CPU minutes to work with. That is still the case today. We have about 800,000 systems to worry about in security and about 300,000 people on our team.
And when it comes to innovation and the value of innovation to an entrepreneurial company, it's critical. Unless you have if it's the other thing that I keep on reminding my team all the time with, if it's not hard, it's not worth doing. If it's not difficult, it's not worth doing. Everybody can do the simple things in life, and you're not going to get compensated for doing them.
Next up is what we call the elevator pitch Olympics.
Digital triage system is the future of automatic vital signs recording. The vital signs are blood pressure, blood oxygen saturation, heart rate, temperature, and respiration rate, and all of these are absolutely crucial to effective emergency room triage. Now, the problem with current process is that the vital sign machines are too bulky, do not measure the respiration rate, and most are unable to automatically document the measurements in the patient's medical records.
Oh, spokespersons. Okay, folks, here's the timer. Don't go over. Go.
In the United States, there are thousands of schools, studios, and performance spaces that use pianos every day. A typical recording studio will have several pianos, and each of which needs to be tuned 3 or 4 times a week. The only way to tune a piano is to hire an expensive technician. It costs up to $200 per tuning. In a busy recording studio, this will add up to about $30,000 a year just to tune one piano.
The Easy Keys system allows anyone, regardless of experience or skill, to tune a piano at the touch of a single button. Our system is a compact, easily movable, easily removable, fully enclosed electromechanical system that is more precise, faster, and more convenient than using a human tuning technician.
ImmunoClue Rapid Diagnostic Device.
Hello, I'm Steve DeFroda. I'm going to be talking to you today about the ImmunoClue Rapid Point-of-Care Diagnostic Device. A point-of-care device is a medical device that can be used at a patient's bedside to diagnose an illness. Now, the illness that we chose to investigate was chlamydia. We chose chlamydia because it's the most prevalent sexually transmitted disease in America, infecting 3 million people annually and costing $175 million in diagnosis alone. Other competitive advantages to our product versus products already available, the current gold standard on the market for chlamydia testing is you go to the doctor sends you to a laboratory. The laboratory takes your urine sample, takes 3 to 5 days to do a cell culture. Sends your results back to the doctor, you have to go there to get your results.
Okay, good. Next, business fundability. Okay, thank you very much. Judges, we've got a big gap here. If we can, we...
And the first prize winner is Immunoglue. Congratulations.
So our project is a diagnostic magnetic assay for chlamydia trachomatis. We have developed a point-of-care diagnostic device which will enable testing results to be delivered to a patient within the span of one visit to a physician's office. This is going to eliminate the need for outsourced laboratories, which are both very costly to the physician and require about a week's time for the patient to wait for their testing results. So the chemistry of this device encompasses a colored polystyrene microsphere that will adsorb protein to its surface. So in an aqueous solution, if protein is present, it's going to collect on the surface of the colored polystyrene bead. There's also magnetic microspheres in the solution, and when the magnetic microspheres encounter a magnetic field, they're going to move towards that magnet. So these are the magnetic microspheres on which, and the movement of these beads is what the project is based on. So when they encounter a magnetic field, the beads are going to start to move towards the magnet. And you can see the solution starting to clear. So all of the magnetic beads are attracted to the source of the magnet. So in a solution that contains chlamydia, the polystyrene microsphere is going to adsorb that chlamydia antigen to its surface. So you're going to get a colored polystyrene bead coated in the chlamydia protein. That protein is then going to be attracted to an antibody on the magnetic bead, and this antibody is specific for chlamydia trachomatis. So you're going to get a complex formation between the colored polystyrene, the chlamydia antigen, and the magnetic microsphere. So when that is then placed in a magnetic field, this complex is going to move towards the source of the magnet. And as this complex moves, it's going to pull the color out of solution. So when chlamydia is present, there's going to be a color change from a blue solution to a clear solution. When there's no chlamydia present in the sample, that complex is not going to form between the colored polystyrene and the magnetic microspheres. So the solution is going to remain blue. As you can see from our testing results, we have been able to obtain positive sample validation. This indicates a negative sample where there is no color change, and this will indicate a positive sample when all of the colored polystyrene has been pulled towards the magnet. This is the device that we are using that is going to aid in detection of chlamydia. The sample is loaded into these 2 Eppendorf tubes at this end. The sample is then, there will be 2 capillary tubes here, which will be raised up and lowered to enter into the Eppendorf tubes. The capillary tubes will load via capillary action and then be returned to the plane of the device. They will then be subject to a magnetic field emanating from this magnet, and so there will be a color change that is evident in this area right here, which is what you will see in these 2 pictures.
Hi, we're Group Easy Keys, a senior design group at Stevens Institute of Technology. We have designed a fully autonomous, fully automated piano tuning mechanism. We began this design in the fall of 2009 with an idea by Patrick Rienzo and Kieran Walters, electrical engineering students here at Stevens. We've proceeded since then with the guidance of Professor Charles Giraldi of the Mechanical Engineering Department. We've learned a vast amount on this project, including motor control, interfacing with electronics, with frequency determination, with audio electronics. A vast amount we have learned about engineering design, sourcing components, designing a system that works integrated with mechanical and electrical components. In the future, we plan on expanding this first generation proof of concept prototype into a second generation market-ready prototype that will be able to tune an entire piano in under 2 hours. It'll be marketable to studios, schools, and conservatories that need to tune their pianos at least weekly at a cost of $200 per tuning per piano. Over the course of a year, this adds up to thousands of dollars per piano. Our product would be an initial one-time investment and would not require any further investment to tune the piano. It